Hello and welcome to Aerospace and Mechanical Engineering Lab 1. Today we are going to talk about Lab 9, Manufacturing 1. So in today's lecture we are going to talk about different types of manufacturing. We are going to focus on additive manufacturing and 3D printing, and eventually we will summarize what you will do in the lab and what kind of results you need to obtain from the lab. Okay. We have two main manufacturing types. One is called subtractive manufacturing, and the other one is called additive manufacturing. So by subtractive manufacturing, we mean that we usually start from a big block of metal, plastic, or whatever, and then we build our object, whatever that is, by removing parts of the block. You can see subtractive manufacturing techniques in CNC, for example, in CNC machines, for example. Additive manufacturing, on the other hand, doesn't start with a solid block. It only starts with a CAD model and some sort of a PLA resin or epoxy, and then builds the object a layer by layer, and each layer bonds to the previous layer. Essentially, we are adding layers to our object thing that we want to print. I guess the most famous type of additive manufacturing is 3D printing. Let's talk a little bit more about each type of manufacturing. Subtractive manufacturing, as we said before, it starts with a solid block or bar or like plastic rods or essentially a block of something, and then we remove parts of it, either controlled by a person or a machine, through cutting, boring, drilling, and grinding. Subtractive manufacturing itself can include different processes. For example, CNC machining is one of the subtractive manufacturing techniques. CNC machining is used usually for hard thermoplastics, thermoset plastics, soft metals, and hard metals. Another type of subtractive manufacturing is called electrical discharge machining, or EDMs. Electrical discharge machining is done by the machining part of it is done by creating an arc discharge essentially, and it's usually used for hard metals. Another type of subtractive manufacturing is laser cutting, which is used for thermoplastic, wood, acrylic, fabric, metals. And the last one, which is a machine we have here in our machine shop, is called the water jet cutting. Water jet cutting is used for plastics, hard and soft metals, stone, glass, composite, essentially everything that needs precision cutting. Additive manufacturing, on the other hand, also has different processes. It's not just one 3D printing process, but as we said, most of them, all of them essentially, include creating the first layer based on a CAD model, based on a sliced version of your CAD model, and then put another layer on top of it. And the material of these layers must be a type of material that can bond to the previous layer. That's why in our lab we actually use a PLA. We melt that plastic and then put another layer on top of that melted plastic while it is still a bit hot and can bond to like other plastic. So it has different processes. As I said, the first process that we want to talk about is called stereolithography. We have a video that we want to watch for stereolithography. It's a 50-second video, so I'm just going to let it play.
After a layer is imaged on the resin surface, an elevator system shifts the build platform
This wasn't an advertisement for Proto Labs. So just their video. Another type of additive manufacturing process is called selective laser sintering. It's used for to build engineering thermoplastics such as nylon. Another video.
Once the nylon powder is loaded in the supply container and digital instructions are programmed, the laser unit directs a high-powered beam to a reflective mirror. From there, a galvo letter system steers the focused beam to the powder surface. Each layer of part geometry is then sintered into a heated bed of nylon. Pistons move the supply container up and the build chamber down, while a roller moves across the bed to distribute the next layer of powder. Excess powder is captured in the collection container. The process is repeated layer by layer until the build is complete. Need quality.
And the type of the manufacturing process, 3D printing manufacturing process that we want to use in the lab next week is called fused deposition molding, or FDM. It's used for standard thermoplastics. Like we use a standard thermoplastic to build our objects, whatever that object is, and it follows a different process. As you can see, this is Ultimaker 2. It's one of the 3D printers we have in the lab. Is Ultimaker, a different version of Ultimaker, but it looks very similar to this. As you can see, there is a nozzle right here. As you can see, there's a nozzle that is heated nozzle, and the PLA comes through these lines, the supply lines, to the nozzle, heated, melted, and then applied to the bed layer by layer. There are other additive manufacturing processes that exist out there that are not of our interest, like the material jetting process, binder jetting process, selective laser melting, and electron beam melting, that are additive manufacturing processes. As I said, we are going to focus on fused deposition molding process. We have 3D printers, and there we 3D printers. These are pretty reliable and cheap 3D printers that we I guess can keep using. And you are welcome to go to the labs anytime. Just have to make an appointment with your TA or me to use the 3D printers if you want to. There are also free 3D printers laid out there in the lobby. Okay, so which one of these manufacturing processes is better, additive manufacturing or the subtractive manufacturing? There is no one answer to this. You just have to see what you need and what fits your design best. But if you want to give a comparison, as far as the equipment cost goes, a professional desktop printer usually starts at $3,500, but that is true for a professional desktop printer. If you want to use something at home, you can buy an Ender for $150. But larger scale industrial machines are usually much more expensive. CNC machines also usually start around $2,000 for a home version. You can also build a CNC machine yourself pretty cheaply using Arduinos. So equipment cost for both of them can be pretty low. Then training wise, additive manufacturing 3D printers are usually plug and play. You can just, as long as you know how to create a CAD model, you can use a slicing software that comes with the 3D printers, print your material, and be done with it. On the other hand, CNC machines usually require a little bit of training, maintenance, and jobs, so more than 3D printers. So additive manufacturing training wise is going to cost a little bit less to us. Additive manufacturing usually requires less facility. Smaller rooms are fine. We can have very small 3D printers set up. They don't need heavy cooling. They don't need anything special. As long as you have a hood in your room, you should be fine. And with the home versions, you don't even need to have a hood installed. So as far as the facility requirements with additive manufacturing are usually less. They require the smaller rooms, and they will cost us less as far as the facility requirements goes. 3D printers also don't need specific tools. They usually, specifically the FDM 3D printers, don't need curing, don't need washing, they do need washing a little bit, but they require less complicated tools, if that makes any sense. So as far as the cost of manufacturing something goes, 3D printers are a little bit ahead compared to or additive manufacturing processes, a little bit ahead compared to subtractive manufacturing processes, but it really depends on what you need, what your design needs, which one of these processes to choose from. In the lab, we are going to use the fused deposition molding that was developed by Scott and Lisa Crump in the late 80s. It's also known as fused filament fabrication, which is essentially pretty simple. You have a filament spool, you have a motor that is essentially pushing this spool in. There is a heated nozzle that is going to melt your spool and then create the layers, like these two pictures. Yeah. In the lab, you will be asked to 3D print 3 or more rectangular shaped samples with different infill densities. So our focus is going to be on building a rectangular shape. You will be given the sizing and everything. Just have to change the infill density. And then we want to use those printed samples and do a bending test, 3-point bending. We have already done the 3D-point bending test. We already know what it is. Where you're going to use a Mark 10 force cell to do a 3-point bending test, and we want to see which one is stronger. So essentially, you 3D print a sample, you measure the time it takes to print, and then you measure the deflection versus a specific force. Then you can create care fits for your 3D printed material, and you can give us a functionality. Essentially, you can give us how much time it takes versus the infill density, and you can give us the force structural integrity versus the infill density. Yeah. So the goals of the lab are to investigate the effects of infill density on the printing speed, investigate the effect of infill density on the structural integrity of the printed samples, and learn how to use a 3D printer. That is it for today. Thank you for joining us, and I hope you enjoy the rest of the day.